Now here we would like to evaluate this multiple integral or this double integral over the region R, where the region R is given by these boundaries. So first let's see what the region would look. So the graph of the boundaries will look like, or the region would look like this parallelogram, where the boundaries are the lines x minus y equals 0, x minus y equals 2, and x plus y equals, here I have gotten them, no, not mislabeled, I'm sorry. So x plus y equals 0 is one boundary, and here is the other one, x plus y equals 3. Okay, so what we would do here is that we will just change the variables exactly as we did in the case of one variable, and you are also used to doing that for the polar transformations. So let me recall the rule that we are using. So let's assume that or let's just replace this x minus u with a new variable u, and x plus y with the variable v. So if we do that, what we would get is, now note that the vertices of this region are 0, 0, 1, negative 1, and then 5 over 2, 1 over 2, and 3 over 2, 3 over 2. So what we have with this transformation is that this point 0, 0, of course, gets mapped to 0, 0, and then this 1, negative 1, just substitute the values in there. You will see that that gets mapped to what? 2, 0, and likewise this 3 over 2, 3 over, I'm sorry, this point gets mapped here, and then 5 over 2, 1 over 2 will get mapped at where? At 2, 3. Alright, so writing that, so what we got now is that this yellow region here in the xy region or xy plane gets mapped into UV plane according to this, and you may note that here the coordinates of this point are what? 2, 3. Okay, so when we make the transformation from xy to uv in this manner, if we add these two equations, what shall we get is this, that u plus v is 2x, meaning thereby that x is 1/2 u plus v, and if you did this, that, sorry about that, if you subtracted this equation from this equation, then a similar algebra will tell you that y is 1/2 negative v minus u, or say simply negative u plus v. Okay, so these are x and y in terms of u and v. So when we make the transformation, then what will happen is that if we call this area, this region is R, let's call this region say A. Okay, then according to the transformation, what we have is, so this integral that we would like to evaluate, that will be, first let's do this for sake of our future calculation, that factor this x square minus y square, because that will factor into x plus y and times x minus y, which is like easily visible in our example here. So the quantity x plus y times e to the power x plus y times x minus y will simply become v times e to the vu, and so this is what this portion will become. And if we take the limits of the integral, you can see it's a simple rectangle. U changes from 0 to 2, v changes from 0 to 3. So what we would do is, let's integrate with respect to u first, because that will make this easier. So we will keep v as the outer integral. So we write the limits of v as from 0 to 3, and then for the limit of u, what we have is that we have this limit as limit from 0 to 2. Okay, and then we got our v times e to the power vu, and then what we will have is that we will have the transformation. So here we got this, or rather absolute value. In this case, you have absolute value of this determinant. I'm not putting the absolute value signs here, because what would happen is that this here the value turns out to be positive. But anyways, so here you have dx du, and then you will have dx dv. Okay, and then you would have dy du and dy dv. Okay, so we got dy du and then dy dv, and now we have everything in terms of u and v here, and we are integrating with respect to u first, so we will write du dv. Now this determinant, I mean, you can see from these expressions right above, is that this part here is simply how much? This is 1/2, right? Okay, 1 over 2, and dx dv would also be how much? That is also 1 over 2, right? Okay, now dy du would be negative 1 over 2. Okay, and then dy dv is positive 1 over 2, and this determinant is going to become how much? That determinant is going to be, I think this would be how much? 1/2, because it will be 1/4 plus 1/4, right? Let's just check it. So this whole thing would be how much then? This would be right here. Let me just erase this. And here we got 1/2. If it was a negative value, you could take the absolute value and you just compute it as a regular iterated integral. What it will be is e to the 6 over 4 minus 7 over 4. So let me know if there is anything that you were not able to follow. All right. Thank you.